All right, so this is the day 2 video. You'll want to have the day 2 notes packet out to be working through. We're going to work more with parametric equations in this video, but we're going to focus mostly on trig ones. To eliminate the parameter with a trig parametric equation, we want to use our Pythagorean property that sine squared theta plus cos squared theta equals 1. We could rewrite our x and y components. We can rewrite the x as x over 4 equals sine theta, and y over 4 equals cos theta. So therefore, when we sub them in, the x over 4 can be subbed in for sine, giving us x squared over 16. Same idea for the y over 4 with the cos, giving us plus y squared over 16 equals 1. And if you multiplied the 16 over, that's just x squared plus y squared equals 16. So hopefully that is familiar to you as a circle. Our parameter here was the theta. So we're going to do our nice values. We'll do 0, we'll do pi over 2, pi, 3 pi over 2, and 2 pi. And the reason for this is this will get our orientation for us. So when we sub in, so the x was the sine, but we had a coefficient of 4, so sub in the 0, 4 times 0 is 0. Sub in pi over 2 for the sine, we'll get 4 times 1, so we'll get 4. And keep going, we get 0, negative 4, back to 0. When we do the coses, cos starts at 1, so 1 times 4 is 4. So we'll have 4, 0, negative 4, 0, and back to 4. So we can plot those now. So we've got 0, 4 to start out. So we're starting right here. And then next we're going to 4, 0, so we're going here. So essentially that tells us that our orientation of the circle is going this way. So we can put our arrows on it. So down at the bottom, notice we've switched the cos and the sine. So if we got x by itself, or got cos by itself, we would have x over 4 equals cos theta. We would have y over 4 equals sine theta. Oops, that should be a 4, not a y. So when we sub this into our Pythagorean property, again, we're going to get x squared over 16 plus y squared over 16 equals 1. Or in other words, x squared plus y squared equals 16. So notice exact same equation. But when we go to look at our thetas, so our x's are the coses now. So we have 4, 0, negative 4, 0, back to 4. And our y's are the sines. So we start at 0, 0, 4, 0, negative 4, and 0. So now our first point is at 4, 0. And the second one is at 0, 4. And then we go around this way. So different starting point and different orientation for our circle. So if we flip to the next page, in general, if we have a parametric trig function where the coefficient of cos and sine is the same, it will have the shape of a circle. And then after plotting that circle, you've just got to think about which direction it is going. So the orientation will be different depending on which one the sine and the cos is with. All right, going down to the bottom, we're going to do a similar type idea to eliminate the parameter. So we'll have x over 4 equals cos theta, and we'll have y over 2 equals sine theta. So when we put that into our Pythagorean property, we're going to have x squared over 16 plus y squared over 4 equals 1. Well, those bases are the same, so that's not a circle. We've got a plus, so this is an ellipse. If we do our nice values of theta again, for the x's, we had 4 cos theta, so we'll start at 4, then 0, negative 4, 0, and back to 4. For the y's, we had 2 sine theta, so we'll start at 0. We'll have 0, 2, 0, negative 2, and back to 0. So we're starting out at 4, 0. Then we've got 0, 2, and goes around, so that gives us our orientation for us to put our arrows on. So if we flip to the next page, to our general rule, if we've got a parametric with sines and coses, but the coefficients are different, then that will create an ellipse. And then be sure to think about it to decide which direction your arrows are going. So down on the bottom now we have secant and we have tangent. So our Pythagorean property with secant and tangent, we have tan squared theta plus 1 equals secant squared theta. So if we work to get the x and the y by itself, we will have that y over 3 is equal to tan theta, and we've got x over 2 equals secant theta. So filling those in, that would give us y squared over 9 plus 1 equals x squared over 4. So working to get the 1 alone, we'll end up with x squared over 4 minus y squared over 9 is equal to 1. So this would be a hyperbola. So again, we will do our nice values for theta. So if we work with the x, which was the secant, keep in mind secant is 1 over cos. So cos at 0 is 1, so the reciprocal of 1 is itself, so we just get 2. But at pi over 2, cos is 0, so its reciprocal would be something over 0, which is undefined. When we put in pi to cos, we'll get negative 1, so its reciprocal is negative 1, we'll get negative 2. And if we keep going, we'll get undefined, and then we will also get 2. When we do it for y, tan of 0 is just 0, but tan of pi over 2 is undefined. Then we'll get 0, we'll get undefined, and then we'll get back to 0. So because we have these undefined, it might be helpful to find some values in between. So let's do the multiples of 45 that are in between. So we're going to do pi over 4, we'll do 3 pi over 4, 5 pi over 4, and 7 pi over 4. So for pi over 4, for the x's, remember that's secant. So So secant, or a cosine of pi over 4 would be 1 over square root of 2, so its reciprocal would be just square root of 2. Multiplying it by 2 gives us 2 square root of 2. And then for the others, it'll just change depending on the quadrant with our ASTC. So in the second quadrant, secant's negative, so we'll have negative 2 square root of 2. Third quadrant, it's negative again. And fourth quadrant, it is positive. For tangent of pi over 4 is just 1. So 1 times 3 is 3, so we're positive in the first, negative in the second for tangent, positive in the third, and then we are back to negative in the fourth. So that'll give us just a little bit more information to help guide us with the graph. So when you graphed a hyperbola last year, you often made a little box to help you draw the asymptotes. So our first point is going to be 2, 0. But then we need to know which asymptote are we approaching, the one up in the first quadrant or the fourth quadrant? Well, that's where the pi over 4 helps. We're going to do square root of 2 over 2, 3, which that means we're going to go towards the asymptote this way. Okay, so we'll put our arrows there. Well, then the next point we would get to is the undefined, the pi over 2. So after that, we'll look at the 3 pi over 4. Well, that's a negative and a negative, so that's in the third quadrant. So essentially what's happening is we're getting closer and closer to this asymptote. On the asymptote, we're undefined, but then just on the other side, we basically appear over here. Because our next nice point after that is the negative 2, 0. The 5 pi over 4 gave us a negative x and a positive y, so that's why that goes into the second quadrant. And then essentially it kind of goes out along the asymptote and gets closer and closer, and then once it gets to the other side of the asymptote, it ends up filling in down here. So we'll put our arrows back on like that. Okay, so we started at that spot at 2, 0, kind of went to the first quadrant, then to the third, then to the second, and then to the fourth. So if we flip the page, we'll look at another example of one of these. All right, so we have a similar idea here. We'll have x over 3 is equal to tan theta. We have y over 2 equals secant theta. So when we use our Pythagorean property, we'll have x squared over 9 plus 1 is equal to y squared over 4. So this time the y part is positive as we subtract the x squared over 9 over. So that tells us we've got a hyperbola. Based on what we saw last time, I'm going to insert the multiples of pi over 4 as I go through here. So we're going to have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and then 2 pi. So for x's, we have the tangents this time. So first let's do the non-pi over 4 ones. Tan of 0 gave us 0. Then the pi over 2 was undefined. Then the pi was back to 0. 3 pi over 2 is undefined. 2 pi is back to 0. And then for tan, the 45s gave us 1. So it's just dependent on the quadrant. So we had 3 in the first quadrant, negative 3 second quadrant, 3 in the third, negative 3 in the fourth. For the y's, we had the secant. So cos of 0 is 1. Its reciprocal is 1. 1 times 2 is 2. And we'll go through, we'll do the nice ones again. Cos of pi over 2 is 0. Reciprocal of 0 would give us an undefined. then we'll have a negative 2, then an undefined, and then back to 2. And then for our multiples of 45, cos is 1 over square root of 2. Its reciprocal is square root of 2. Times the 2 gives us 2 square root of 2. We're positive in the first, negative in the second, negative in the third, positive in the fourth. So we can make our little box to help us draw the asymptotes. So our first point here is 0, 2. And then based on the pi over 4, we're in the first quadrant. So essentially that just tells us we're going to go out in this direction. Now based on what we saw in the last one, just knowing that, we could probably draw the rest of it, because if it's going out along that asymptote just to the left of it, it's going to come back on the right side of that asymptote in the other quadrant. So we'll put some arrows on that, and then this asymptote, as it goes along that bottom side, when it comes back, it'll come out on the top side, and we'll stick some arrows on that. And if we weren't sure of that, we could just do the points as well. So down on the bottom, if we have secants and tangents, and we have the coefficients there, these would be hyperbolas. All right, the last page, we want to rewrite in, each parametric equation in rectangular form. So we want to eliminate the parameter. So we're going to do pretty much what we've been doing. We just have one extra step. So here for the x, we've got to first subtract the h over, and then we'll divide by a. And that's what cos theta will be. For the y, we've got to subtract the k over and divide by b. So that's what sine theta will be. And if we sub those into our Pythagorean property, we'll end up getting an x minus h squared over a squared plus a y minus k squared over b squared equals 1. And again, that's coming from subbing into sine squared theta plus cos squared theta equals 1. I guess technically we subbed it into cos squared theta plus sine squared theta equals 1. We've got 2 parts squared. The bases are different. And it's a plus, so this is an ellipse. And our last one, we've just got cosecant and cotangent, so we'll work to get them alone first. So we'll have x minus h over a is equal to cosecant theta. And we'll have y minus k over b is equal to cotangent theta. Now our Pythagorean property involving those is 1 plus cotangent squared theta equals cosecant squared theta. So when we get the 1 by itself, we're really going to do cosecant squared theta minus cotangent squared theta. So in our case, if we fill in our cosecant theta, that's going to be x minus h squared over a squared minus y minus k squared over b squared. We've got both parts squared, we've got a minus, so this would be a hyperbola. And that's it for the day 2 video. That concludes our review of the parametric equations from last year.